Now, it's not every day you get to come to a place like this. We're here in Barcelona at HP. We're here at HP's global additive manufacturing solutions hub. I feel like I'm on the cusp of technology.
Well, look, it's great to be here in Spain at HP, an amazing facility. Can't wait to show you. Let's go inside, talk to Joe.
Hiya, Joe.
Hi.
It's so good to be here and see you in Barcelona as well.
Welcome to the Experience Centre.
So this is the showroom, right?
Yes, so this is basically giving you a snapshot into some of the applications that HP are involved in. As you know, we're going to take you into the labs where you can see the R&D facility, and you'll also see the engineering department, which houses some of the best engineers in the world.
I mean, Joe, like, there's products here that I recognise.
And this is it. You've got consumer goods, medical devices, and what we're showcasing here is all end-use applications. These aren't just gimmicks. These are all being used in industry.
Yeah, we've done case studies on some of those.
Yeah, the cranial caps, so they are sold into the UK medical market through the NHS, private clinics. What you've got here is a seat that basically goes into certain Porsches. If you've got enough money, you can have custom seats fitted to you.
Oh my gosh!
One of the benefits of this structure is it uses a lattice structure as opposed to a foam, which is not as breathable, and you can't get sort of electronics through it as easily.
I recognise so many brands here, look, oh wow.
Yes, so there aren't many brands that aren't utilising HP's technology now, either through their own machines or outsourcing through subcontract suppliers.
But it's not just cosmetic, is it?
No, it's basically, the majority of components are actually mechanical or end-use components that go behind the dash or under the bonnet, like covers, clips, that sort of thing. Metals, so HP, as you know, and John's going to talk about it more later on today, is the advancements into the metals market.
My goodness.
And this is now volume additive manufacturing of metal components.
I mean, you know, industry, subtractive industry, this is on another.
Exactly, this appeals more to our CNC customer base because they machine. Yeah, exactly. So what we're doing here is maybe near net shape components, and then it's a minimal machining operation after that.
Wow.
Another advancement, HP, and a part of the R&D for it is done in this facility here, is the new FR material, so
This
flame
is
retardant.
batteries?
Yeah, so basically electronic components is a real good market for us. So typically we wouldn't have been able to get into this market because the materials just weren't up to the rating. Now with this new material, it's just opened up for more applications for us to attack. So
You excited about all this?
very excited. Well, the more materials, the more applications we can get involved with.
John, this place is so vast.
I mean, look at the size of the place.
It is amazing. So what actually goes on here then?
So what I understand we've got in here is a combination of workshops and laboratories. It's all about process development, it's all about process efficiency. So hours and hours, weeks and weeks of work go on continuously to make sure the process is optimized, to make sure that the process is efficient, and it's just always plug and play. It's ready to go when you need it.
So on site, you've got your own machines optimizing processes. So when your machines are sold, then you know that you've got like the latest developments and everything is working as
Spot on.
Okay.
Yeah, and it's all about creating manufacturing efficiency and just de-risking the process. A lot of people are still a little bit anxious about additive manufacturing. They really, really shouldn't be. And if you think about the Matsuura business, this metal process is a perfect fit for us, right?
Well, look, I guess it's kind of, you know, you've got additive and subtractive, and
Yeah.
they're always going to collide, aren't they? They're always going to go
they
together.
should. They should. Look, a lot of people look at additive manufacturing as a sort of little island within a business. It's not. It needs to be integrated within your day-to-day running of a manufacturing site.
Yeah, you're trying to demystify it.
Well, no, you have to. You have to, because this process is now ready. These machines can produce 2,000 cubic centimetres of metal per hour. That's volume, okay? And this process is ready to deliver volume.
So you're telling me industry needs to start considering additive manufacturing within the metals industry?
Absolutely, absolutely. It's the perfect timing for that to do it. And this is a product which we're looking to engage with. I think the time is right for Matsuura to look at this product in much more detail and bring it into our portfolio.
But it's not just metals that you do here, is it?
It's not, no. There's polymers down the other end of the building. This building, it takes on all of those facilities.
Right, I'll go see those then.
And this, Lyndsey, is exactly why we wanted to bring you here, because this is an opportunity to see behind the scenes. Not everybody gets the opportunity to come here, but this just shows you the investment HP are making in the 3D business.
It's just machine after machine after machine. It's incredible.
That's it. Over the site here, you've got 100 machines, basically constantly running validation builds.
And who are the people here who are working?
So yeah, a lot of these guys are engineers, technicians. They all have specific roles. Some will be developing maybe the software, some are developing the reliability of the process. You've got materials scientists here, so they think about everything.
Oh, so much. And is this a build?
Yeah, so this is basically a test build. So what they do here is basically they create a number of artifacts, as you call it, and what they do is they print them in multiple locations around the build to try and improve the reliability and consistency of each build, because that's one thing I think where a lot of 3D technologies fall down is you can make one component, but how do you repeat the process reliably, consistently over and over again? And that's something HP have invested heavily in.
It's production.
Yeah, it is. That's it. And this is just another way to produce polymer components. And I think if people think about it in that way, as opposed to thinking, you know, is it going to replace this technology? Is it going to replace that technology? No, it's just a new way to manufacture.
I guess.
And there's a place for everything. There always will be. You know, there's a place for injection molding. There's a place for CNC machining. But there's now a place for additive manufacturing.
I guess when people buy a machine,
Yep.
a HP machine from Matsuura or anywhere really, you don't realise what's behind it,
Yeah.
what support network you've got, and it's not just here, is it?
No, that's it. You think, yeah, you've got this facility here. I mean, you look at the size of the facility and you think, are they manufacturing it? No, this is just purely validating the machine, improving the process, making it better. There's still facilities where they manufacture out in Singapore, the US. It's a monstrous organisation, and that's what you're buying into. You're not just buying a machine from Matsuura, you're buying a machine from HP.
What a wonderful place this is. Thank you so much for
problem.
letting us have a tour here. And,
No, thanks for coming over.
you know, what would you say, and where would you say we're at with additive manufacturing?
Yeah, I think it is literally the tip of the iceberg. I think, yeah, there's so much potential. I mean, if you look at how far we've come in just that short space of time,
Yeah.
where it went from prototyping, say, 30 years ago, to now having end-use production components going out into the field in automotive, medical, consumer, that is, you know, groundbreaking in itself. You think in another 30 years' time where we'll be?
Where we'll be?
Yeah.
It's impressive.
Thank you.